Signum function. Next is Signum function. The function f from R to R, set of real numbers, defined by fx equal to 1 if x positive, output is 0 if x equal to 0, and output is minus 1 if x less than 0. See what is the meaning of this function? Here f is from R to R, domain is R, codomain is R. R contains positive as well as negative, all real numbers. Here R is set of all real numbers. Now from set of real numbers in this machine, if I keep suppose 5 is positive, 5. Now 5 is more than 0. 5 is more than 0, so f of 5 is 1. If I take 6 is more than 0, so f of 6 is 1. If you take suppose 50 is more than 0, so f of 50 is 1. Take any positive, suppose root 15, f of root 15 is 1 because root 15 is more than 0. If we take, suppose I take minus 5, input is minus 5 is less than 0, so f of minus 5 is minus 1. If we take minus 6 is less than 0, so f of minus 6 is minus 1. F of minus 11 by 2 is less than 0, so f of minus 11 by 2 is minus 1. If we keep 0, if input is 0, output is 0. It is 0. So you can see that when we take here positive value, output is 1, and when we take here negative values, these are negative, output is minus 1. So outputs are plus 1, outputs are minus 1 or 0. So it is like when we take positive number, output is plus 1. When we take negative number, output is minus 1. So that means like function is giving sign only. So it's said to be sign of function. Only 3 images. For every real image is either plus 1 or minus 1 or 0. So here range of this function is, range of this sign of function is, range contains only 3 values, minus 1, 0 and 1. Greatest integer function. A function f whose domain is set of real numbers, codomain is set of real numbers, defined by fx equal to box value of x. Fx is box value of x. It's a one type of machine. If you keep any real number x from set of real numbers, take any number. The number comes in this box. Machine keeps that number in box. Now what box does? Box of x equal to the greatest integer not greater than x. Box of x is equal to the greatest integer not greater than x. See, explaining this by example, what is the meaning of bunch of these words? Domain is R. Domain is R. This is set of real numbers. I show here picture of domain. Suppose here 0, 1, 2, 3, -1, -2 like that. Domain of this function is R, so in this machine we can keep any real number. Suppose I am putting value, suppose I am taking 2.1, 2.1 is here. So f of 2.1, f of 2.1 is box of 2.1. Now box of 2.1 is the greatest integer not greater than 2.1. Read this meaning by putting here 2.1. Box of 2.1 is what? The greatest integer not greater than 2.1. Greatest integer not greater than 2.1. See, not greater than 2.1 is not seen on the left side. On the right hand side, all numbers are greater than 2.1. According to this meaning, output is not greater than 2.1. Integer not greater than 2.1. So which is that integer? So greatest integer not greater than 2.1 is not take from this side. So that means required integer is on left side. So it can be that number or less than that number. But it is greatest integer. So on left side of 2.1, these are integers 2, 1, 0, -1. So these are integers not greater than 2.1. Among these, which is greatest? Among these, greatest is 2. So take greatest. So that is 2. Now suppose I take 2.5. F of 2.5 is box value of 2.5. Box value of 2.5. The greatest integer not greater than 2.5. Not greater than 2.5 is not seen on the right side. All these integers are greater than 2.5. So observe numbers which are equal to 2.5 and less than 2.5. So required output is integer not greater than 2.5. Integer not greater than 2.5. That means it will be given number or less than that number. And less than that number, these are integers. These are the integers which are not greater than 2.5. So among this, which is greatest? So among this, who is greatest? So output is, if I take 2.9, 2.9 somewhere here, box value of 2.9. The greatest integer not greater than 2.9. Integer not greater than 2.9. So integer not greater than 2.9 means don't take 3, don't take 4, don't take 5, don't take integers which are on right side. So observe integers which are on left side or even number. Now among these which are smaller than 2.9, which is the greatest integer? So on the left side of 2.9, greatest integer is 2. So here output is See, you can see that if we take 2.1, box value of 2.1 is 2, box value of 2.5 is 2, box value of 2.9 is 2, box value of 2.7 is 2. Similarly, it will be 2. If you take box value of 2.999, so every time create number line in your mind. On number line 2.999. So think location of 2.999. Then take output, which is the left side first integer. So which is the left side first integer? So on 2.999, left side of 2.999, the first integer is 2. So output is 2. So don't take integer from right side. Take from left side. Left side very first integer. So 2. If you take 2, box value of 2, box value of 2. So box value of 2, the greatest integer not greater than 2. Not greater than 2 means don't take 3, don't take 4, don't take 5. Not greater than 2. Instruction is not greater than 2. That means you can think for 2. You can consider 2. Don't consider greater than 2. So don't consider 3, 4, 5. So accepting integers greater than 2, these integers are left, which are smaller than 2 and number itself is also integer. So among these integers, which is the greatest? So greatest is 2 itself. So it is 2. So remember, when you take an integer, output is itself. But if number is not integer, then what is output? Output is the integer which is on left side. Very first integer which is on left side of that number. On left side of 2.5, integer is 2. On left side of 2.9, integer is 2. Left side means you have to take from number line. Number line, left side integer, left side to 2.7, the very first integer is 2. Left side to 2.999, very first integer is 2. So if you take any number from this part, from 2 to 3. Now if I take here 3, take here 3. So the greatest integer not greater than 3. Greatest integer not greater than 3 means not take 4, 5, 6. So consider 3 itself or all integers which are smaller than that number. So not greater than 3. Greatest integer not greater than 3 means not take 4, 5, 6. So the greatest which is on this side is 3 itself. So we take here 3. Box value of 3 is 3. Let me explain on other diagram. Here this is 3, this is 4. So first I will take 3. Now if you take 3.2, 3.2 somewhere here, the box value of 3.2, so which is the first integer on left of 3.2 is 3. So it is 3. If I take 3.7, the box value of 3.7 is 3. Here this is 3.7. The left side very first integer is 3. So when you take any number which is integer, keep as it is. If not integer, take the first integer which is on left side of that number. So from this discussion, if we take from 3 to up to 4, don't take 4. See, output is 3 for x equal to 3 and numbers which are more than 3. But when you take here 3.999. If you take here 1000 times 9, even though value is 3. But as you take 4, then output will be changed 4. So from this explanation, from this diagram, what we can say that fx equal to output is 2, box x equal to 2, fx equal to 2, constant 2. If x is taken from this interval, if x is taken between from 2 to 3, so these values are from 2 to 3, and for x equal to 2 also output is 2, so we can join here 2. F of 2 is 2, but we can't join 3. You can take 3 because f of 3 is not 2. Then after 2 to 3, next interval is 3 to 4. So now putting statement for this part. If x is taken from 3 to 4, including 3, then fx equal to box x equal to 3. Continuing this procedure, if you take x from 4 to 5, if input is from this interval, then fx equal to box value of x is 4. This can be continued. Similarly, say here, on the left of 2 to 3, now I am putting statement for this interval 1 to 2. 1 to 2. So if x is between 1 to 2, then fx is equal to 1. Now coming on this side, 0 to 1. 0 to 1. If fx is x is between 0 and 1, then fx equal to box x equal to 0. Now this side, minus 1 to 0. Minus 1 to 0. This is minus 1. This is 0. So here, if you observe these numbers between minus 1 and 0, this may be minus 0.5, this may be minus 0.6, this may be minus 0.7. You see, f of minus 0.7 is minus 1. F of minus 0.6 is minus 1. F of minus 0.5 is minus 1, like this. So if x is from minus 1 and 0, then fx equal to minus 1. Now taking this part, minus 2 to minus 1, minus 2 to minus 1. Between minus 2 to minus 1, suppose this number is minus 1.7, this is minus 1.6, this is minus 1.5. Now I am putting here minus 1.5, minus 1.9, such type of numbers I am putting here, which are belonging to this interval. F of minus 1.5. So on left of minus 1.5, which is the first integer? Minus 2. So it is minus 2. F of minus 1.7. So which is the number, very first integer of minus 1.7. So it is minus 2. So this is box value of minus 1.5. This is what? Box value of minus 1.7, minus 2. when we were getting the positive numbers, you can see that here output is the integer part of that number. The 3.2 integer part is 3, so output is 3. Here integer part is 3, output is 3. But remember, the number is negative. The integer part is not minus 1. This is not similar to this pattern. So you do not memorize by this way. Then output is the integer which is on the left side of decimal point. Here it is not minus 1. For positive numbers, you can memorize like that. If the number is positive, the output is the number which is on the left of that decimal point. But here same is not true. But what is the actual method? Method is you create number line. You need box value of minus 1.7. Now take minus 1.7, so which is the first integer on the left of minus 1.7. The first integer on left of minus 1.7 is minus 2. The output is minus 2. So this is the correct value. So when x is between minus 2 and minus 1, then fx is equal to minus 2. So we can continue. This procedure can be continued for every interval which is subset of set of real numbers. Now see, here a procedure was, in short, we can express by this way. This is set of real numbers. N is any integer. This is integer. Any integer. If suppose this is 7, so after 7, next integer is 8. If this is 10, so this will be 11. So here I think n plus 1. If n is integer, on the left side, the next integer is n minus 1. This number is 15, so this will be 40, like that. Now, if x is number which is taken from this interval, x is number such that x lies between n minus 1 to n. X is any integer between x is any integer belonging to this interval, then box of x equal to left side first integer. If x is any number from this interval, then its box value is left side first integer. And if x is integer n minus 1, then also value is n minus 1, like this. This is n, so this is n minus 1. This number is n, this is n minus 1. So here we give sign of equality. If similarly statement for this side, if x is an integer in this part, if x is between n to n plus 1 or equal to n, then its box value is equal to n. Now, graph of this function can be expressed as, see, domain is shown on set of real line. This is x-axis. This line is y-axis. Therefore, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. See. fx means value of y. Y is equal to 2. If x is value belonging to 2 to 3, that means f of 2 is 2. F of 2 is 2. Box value of 2 is 2. Box value of 2 is 2. Box value of 2.1 is 2. Box value of 2.2 is 2. Showing this line on graph, box value of 2 is 2. Box value of 2.1 is also 2. Box value of 2.2 is also 2. Box value of 2.5 is 2. See, value of y is constant. Y means fx. It is constant if you take x from 2 to 3, including 2. So when x assumes value from this interval, x equal to 2, x equal to 2.1, x equal to 2.2, up to 2.999. 2.999. Not take x equal to 3. So here I keep deleted point. So x equal to 2, its image is 2. Image of 2.1 is 2. Image of 2.2 is 2. Image of 2.3 is 2. Image, so continuing this procedure, image of all the numbers in this part is 2. So here this point is included, but this point is excluded. Here this is deleted. Now next line. Image is 3. Image is 3. Y coordinate is 3. When x is 3 to 4. Means box value of 3 is 3. Box value of 3 is 3. Box value of 3.1 is 3. Box value of 3.2 is 3. Box value of 3.4 is 3. Box value of 4 is not 4. Keep deleted. But box value of 3.9 is 3. So presentation of set of points for all x belonging to 3 to 4, including 3, excluding 4. Including 3, excluding 4, all the points are on this line segment, which is one side closed, other side open. This is open end. Delete. Similarly, 1 to 2, if x value is belonging to 1 to 2, then fx is 1. Fx is 1. Y is 1. If x is between 1 to 2. So here, image of 1 is 1, but image of 2 is not 2. Image of 2 is, image of 2 is not 1. Image of 2 is 2. That is discussed here. So, set of points corresponding to x, 1 to 2, 1 included, 2 excluded, it will be this line segment. Similarly, here, y is 0. Y is 0, that means on x-axis these points have y coordinate 0 and x coordinate 0 to 1. 0 to 1. So there, when x is 1, y is not 0, but for x equal to 1, y is 1. That discussed here. Then, see, if x is minus 1, means y is minus 1. If x is from minus 1 to 0, if x is from minus 1 to 0, y is minus 1. Here, these points have y coordinate minus 1. Y coordinate minus 1 corresponding to x coordinates minus 1 to 0. So here, minus 1 to 0. And here, for 0, box 0 is 0. Box 0 is not minus 1. So this point is excluded. Here I am excluding this point. Similarly, for this line, y is minus 2 if x between minus 2 to minus 1. Y is minus 2. Here these points have y coordinate minus 2. But it is for those x, for those points whose x coordinate is from minus 2 to minus 1. So here minus 2, image of minus 2 is minus 2. Image of minus 1 is not minus 2. So in here negative. And all these points are points whose x coordinate is between minus 2 and minus 1, whose image is minus 1. So here we are getting steps. These are steps. So this is the graph of greatest integer function.